I thought you were going to say something about Larkspur. Man, disappointed. Well, anyway, ask me during the questions about Larkspur. Yeah, so I come from the same category of names as Wouter Suirstra, if you were curious about that name from the previous talk. So it's actually Adriaan Moors, but I'm fine with Adriaan. It's really totally fine. And I'm sure Wouter wouldn't mind being called Wouter or something. I don't know what that would become. Anyway, so I'm the team lead at TypeSafe for Scala. The kind of roughly the decade before I went to the dark side. I think I'm just going to take this thing. Roughly like the decade before I went to the dark side, I was in academia and working for a large part with Martin at EPFL. And the first thing I did with Scala was higher kind of types, type constructor polymorphism, or like the crazy types, I don't know, or less kind names that people give them, I guess. Worked a bit on a pattern match or implicit search and so on. So I've been hacking the compiler for a while. And so largely responsible for all the, or not largely, but somewhat responsible for some of the stuff that is in there and that we would like you not to use. And that's kind of why I'm redeeming myself today, somewhat, talking about how you should abide. I'll try to keep my laptop awake. Maybe I should switch slides faster or something. So work for the company currently called TypeSafe. And I should start by some acknowledgements. I actually did very little of the work that I'm going to talk about. I'll try to keep up pretenses that I actually know what I'm talking about. But Nicolas, during his summer internship last year at TypeSafe Switzerland, did a great job. And I borrowed a couple of slides from Julian Dragos, my colleague in Lausanne, who actually led the internship. This is a great need in the community, as I alluded at. Scala doesn't really tell you what not to do. It's kind of proud of not restricting you and not having arbitrary restrictions, which in our minds make for a simpler language because you don't have to remember a lot of the corner cases. It also leads to questionable code that often are specific to what you're doing or where you're working or when you're working there. So clearly a lot of people have felt that need and have come up with various solutions. I'll say it a couple times, but we're not really talking about stuff like Scala style and Scala reform today. So abide really is like your own snarky, picky type checker. So emphasis on type. It doesn't really care about formatting. You can add all the white space and semicolons. Abide will cringe, but it won't tell you anything. Yeah. So why abide? Well, there's lots of aspects of why. Why are we working on abide? Why should you use it? We're working on abide at TypeSafe, and I should acknowledge that we're not working on it as much as I would like because we're kind of busy with 2.12 and Java 8. But we want to invest in the platform side of abide, as we always do with Scala tools, because it's actually pretty tricky to get the rules right. And I think the tools on the previous slide did a great job of getting the rules right for their code bases. But when you go look at them, there's a lot of toStrings and comparisons of types, like begins with array and stuff like that. And we just decided we couldn't take that anymore, and we wanted to open up the compiler, which is basically what abide does, to adding your own rules, and I'll show you how to do that. How to write your own rules, how to use abide, and how to contribute to abide. So as I said, the platform is on us, and so it's built on the Scala compiler. I think one of the worst things with tools like this, if there is some kind of discrepancy between the language that you're enforcing, usage of, and how you're enforcing that. So you get the same view as the type checker gets in the rules, in the abide rules that you can write. And it's written to be extensible, so it's meant really as a plugin infrastructure for all your rules. And that can get slow if you have hundreds of rules. So we do fusion and we do more optimization. We look at like the AST nodes that your rule cares about, and so we make sure we don't run it on the nodes it doesn't care about. And so that's really where we want to invest, making sure that it's fast and correct. And finally, speaking of correctness, you should never do toString on a type. And then say begins with array. Just don't do it. Don't do it. Please ask us if it's not clear from after this talk how to do something like that. But seriously, one of the reasons why there hasn't been an Abid release yet is because these are the criteria for the first release, and we've managed 2 out of 3, but we want to provide you with a slightly nicer layer of really common things that you want to check about your code that currently require quite intricate knowledge of the compiler. And so a big part of the talk today will actually be kind of going into the REPL, the power mode, and show you what the compiler is doing and how you can ask it for things like, is this an array properly? And of course, why Abid? Why is it a platform? Why is it not a big phase that checks whether you're using math correctly? Well, not everybody cares about that. So it might change over time. It might change across teams. Different libraries you could imagine coming with Abid power packs that tell you how to use that library. For example, Akka or something. Don't use sender or whatever. I'm not any means an Akka expert. So that's another reason why Abid is designed as it is. And we would like you to use it productively, starting during your local build from SBT IDE, but we're very happy to open it up to, let's say even Ant users, which I am. I've done thousands. I've written thousands of lines of XML in Ant for the Scala build. But you can't ask me about that during this talk. You can, however, ask me about anything else. So please interrupt me. Please hackle. Keep the larkspur things for at the end of the talk. So code review, I think, is an awesome opportunity, and Codicy is looking at that. Where there's so many aspects of reviewing pull requests, and a lot of them would be nice to get out of the way so that you can actually focus on is this part of my design, like does this fit into the design? There's a lot of low-hanging fruit that we could pick with Abid that you wouldn't have to worry about anymore. I mean, there's a whole methodological kind of question around style checking that I don't want to get too deeply in today, but we don't see this as some kind of system to game or something. It really is meant to let you easily customize, let you suppress warnings that you don't want to see, and give you feedback. I would never put this as an acceptance test with like 200 rules enabled and you have to meet all of them, no exceptions. I don't think that makes sense. And so you could track metrics and have a dashboard and stuff like that. And what I'm implicitly saying is here, like, we're not really doing any of that, but you'd be very welcome, and it would be really awesome to do stuff like that. So a rule, what it does is it hones in syntactically, so you have some fragments of Scala AST in mind, and I'll show you in a minute how to actually write these and how to figure out how to code a rule like that. So you look at some syntactic construction at the AST level, and then you ask the type checker, hey, what do you know about the AST? What is this actually doing semantically? And then it will decide whether it's doing the right thing or not according to this rule. So a couple of examples to give you an idea of what I'm talking about. A private field in a trait, you can do it because you can, you have all these modifiers, you can put fields everywhere. It doesn't make a lot of sense because given the compilation model on Java, so this would not be a rule that you would necessarily activate on the JavaScript backend, but on the JVM, it doesn't make a lot of sense to define a private field in a trait because it will compile into a lot of public stuff. I won't go into the details, but just to give you an example of something that we will never we can't make it in general legal in the spec because we don't really talk too much about how we have to compile this right now into bytecode. But for a lot of people, maybe they want to rule that out. Unused private members. Who are we to say that that's a bad idea at the spec level? But I can think of not very many reasons to do those. And you can match on a seek with : and sometimes that'll do what you want. A lot of times, it will do something else. And so these rules here that I mentioned before, some of them rely on understanding how your code flows. I mean, you could put stuff under if false and say, well, hey, I mean, this never gets executed. Why do I get an error for this? So Abid currently doesn't offer anything like that. That would be awesome. And a couple of PhDs later, maybe we can get there. I mean, I hear Facebook is doing stuff with infer, with separation logic and stuff like that. So that's kind of the other end of the spectrum where we're not there yet. So it has to be, I guess the short of this slide is, it is always going to be an approximation. It's always going to be kind of a way to capture your house style and to kind of prune the low-hanging fruit. But there will be judgment calls, and there needs to be a mechanism to say, hey, trust me, Abid, this is actually fine. You just can't reason about it that well, but I can, hopefully. So the first slide with some code. Currently, this is what it looks like if you want to add it to SBT. We're still polishing the experience there as well, but it's an SBT plugin that will then add a compiler plugin to your compiler. And rule packs are that's great, are dependencies. And the crucial bit was off screen, but here's my nice transition. I'm not a great Reveal.js coder, but just imagine that sliding in and whooshing and sparkling. So you need to put it in the Abid configuration. And those obviously don't end up as a compile time dependency or anything like that. It's kind of like the test category or configuration for dependencies. And so you can easily add your own, and I'll show that during the demo. So for the more serious part, I guess, of the talk, we'll quickly kind of give you an overview of the design, which is extremely complicated. Then we'll level up and kind of play around in the REPL and show you what the ASCs look like, what the type checker can tell you. And I'm sure I'll have plenty of time left for a demo where you can heckle me some more. So the design, obviously you have to traverse ASTs. We provide the mechanisms to fuse multiple traversals that are contributed by multiple rules together, and we optimize so that we don't evaluate a rule if it's never going to match anyway, based purely on syntax. Directive is, I don't know why Nicola decided to name it that way, but it's just some kind of syntax, some repository for state if you wanted to accumulate that in your rule. And then a rule is as a function from tree to unit. Yes, you read that right, to unit. Again, the nomenclature isn't mine. There's an existential rule that is probably the most common type of rule. You want to find a violation. You want to say, like, did something wrong there. So how that works is you find all the potential violations of that rule using not okay, which puts it in a set in your context. And then every time you say, oh wait, this is actually a correct usage, you say, oh okay, this was a good violation. So you kind of gathered a set of potential problems, and then you one by one eliminate them, and those that are left apparently were violating this rule. Very very many rules that you would write in a stat checker can be captured by this. And so in general, there are more types of rules that you can inherit from in the framework that we want to provide so that we can understand how to fuse them and so on. And that you don't have to keep writing, find and exist over trees yourself. That's really what our investment in Abid means. Like we want you to be productive defining your rules and happy using Abid. So let's get into the REPL part of the talk. And this is where I spend a lot of my time when I'm prototyping something. Paul Phillips actually implemented the colon power thing. I won't make any snarky comments about that. But it's a great way. You actually get the compiler that is running in the REPL inside the REPL. So it's extremely meta, and thus extremely awesome. So one of the key constructs that you'll use, at least initially when you're writing your rules in Abid, are Kwazii quotes. Just to see who's still awake, who's used a Kwazii quote, who's never used a Kwazii quote, who doesn't like raising their hands during talks. Okay, just to give me a sense of what the baseline is here. Okay, so I'll talk about it for about, what was that, 60% of what I was planning to do. I wish I was really, really tall. That would be so handy. Oh wait, I have a cursor. Let's do that. So the first part is a pattern that you're assigning the value on the right-hand side to. And the pattern has a placeholder for the modifiers. Then it specifies the keyword must be a def. And again, for the name, a repetition of type parameters, a repetition of arguments, no result type, and a right-hand side. And I'll just point out right away that that's one of the Kwazii quotes' main limitations. As great as they are, they're not very good at specifying that stuff is optional. So this is only going to match something that has a list of type parameters, one argument list with potentially 0 to n arguments, and no result type. So that's one of the gotchas, I guess, and I should ask Dennis if he's planning to do something about that, or maybe I missed it, because I tend to spend my time more in the level below that, that I'll show you in a minute. So if you run this in the REPL, I'm sure no one is surprised that mods will be bound to the modifiers that have private in them. The name is identity, and you have a list of one type parameter and a list of one value definition. If you are surprised, you should probably stop me now. Nope, not surprised. Great. So as I said, I actually spent more time with those glorious trees that are nicely captured by those Kwazii quotes, and when you do show raw, you can see what's actually going on behind the scenes there. So this is a def, and everything else we've seen already, except that this is just has a lot more typing around it, and I don't mean the good kind of typing. But it turns out that they're pretty useful when you want to write rules that capture all possible variations of a syntactic construct. If you wanted to experiment with type checking those Kwazii quotes, here's a minimal way to fire up the type checker. This doesn't fire up a type checker that is actually like the type checker that is type checking your code, but it is pretty close. It doesn't really have the context set up because we don't have a compilation unit and blah blah blah. So it won't do implicits very well. But you can do this to just type check and see what happens on small stuff. So for example. And at any point, if you don't believe me, I'm happy to drop into the REPL and copy paste this and show you that it happens. I don't have color coding in the REPL like here, but otherwise it'll look the same. So let's say you're thinking about writing a rule about classes and methods and references between those methods, and you wanted to see what the type checker produces for you. So it really just does a pretty straightforward transformation here. It normalizes it so that everything has one parent at least. There's a constructor there, and it did some type inference for you for the foo and bar return types here, and it elaborated the prefix. So wherever, we don't have to write this anywhere, obviously, but the type checker is pretty obsessive about these things, so it writes them everywhere. It also likes to write semicolons. I don't know why that is. I think no surprises there. I think this is, I'm telling you because I think this is good to know. I'm not telling you, like, kind of jumping out of a box saying, like, ta-da, look at what this is doing. Maybe where it gets a little more interesting is, like, behind those trees that are kind of obvious, we have symbols and types. Symbols maintain the references between definitions and their references, and the infos of symbols are like the signatures. So in case of a class, it'll be a class info type, which will be printed like this. So it'll tell you the parents, the self variable definition, if any, and then all the members with their respective infos. So .info is an important method on symbol, if you want to look into the definition that the symbol represents. And so every tree, not every tree, but most trees have a symbol. And in the case that a tree defines something, it's the introduction of that symbol. And whenever a tree refers to anything, the symbol will be the symbol that it refers to. Kind of makes sense, doesn't it? There's a distinction between private members, which are very local to the type and not inherited, and everything else. So that's why non-private member is one of those internal methods in the compiler that looks into the universe of kind of non-private members that are in their own category. And you have to specify that it's a term or a type name. Like from parse time, the compiler cares about the distinction between types and terms, and it knows wherever you write something if you're in a position that expects a term or a type. So you have to be explicit about that, otherwise it's not going to find the type name foo if you would write it like that mistakenly. So now we get the symbol that represents the method foo. And let's say then, part of your rule wants to know which methods refer to that method, if any. So you can actually just do collect on a tree, and we have all the boilerplate in the compiler that traverses them and builds up, the result of this partial function that you pass to collect. And I've used a Kwazii quote here. So it's looking for all methods that are exactly like this. So again, if you want more general, I recommend using defdefs, but for the initial prototype, it's great to do it this way. And then we're going to do a super simple thing. I mean, like we're just assuming that the right-hand side is just one expression that top level refers to the method that we just found out what its symbol is, namely foo. So we're looking for all the methods that on the right-hand side, the top-level expression immediately refers to foo. You can imagine how you would generate this and how that would no longer fit on a slide. And in that case, we're going to tell you what the type of that right-hand side is. And I know that there's just one, so why don't I just call head directly? What can go wrong? And luckily, since this is not an actual live coding thing, nothing went wrong because I just copy-pasted this once I made sure that it didn't go wrong. And in this stage, we know that it's it. So is this clear as a construct? Does it make sense? Can you imagine using this in a rule and not using toString and comparisons between method names? Thank you. Great. So one thing that is also interesting to know about symbols is where they are defined, or what the path is to where they are defined. And oh, you're just yawning. I thought you had a question. Oh, stretching. Okay. Good. So an obvious method, to know what it does anyway, but owner chain is what you need to be calling if you want to see like the whole chain of owners. If you want to get a little funkier, you can see things like stuff that we will never show you, surface syntax. So note that the type here actually knows that it's a 1. Like the type checker will actually track all this so that it can do constant folding. And there is a SIP that we're working on exposing this, because you could do a lot of interesting things with that knowledge, obviously. Then a ubiquitous method on types is widen, which brings it back to the most generic kind of class-like type that will capture all those values of int. And yeah, again, I'm showing you this because these might be like some non-obvious things that you might want to know when you're writing a rule that deals with constants or just in general, because we do try always to infer the most specific type when we can internally and widen it later. And now, just to completely knock you out right before lunch, some base type, member type, as seen from fun. Who's ever heard of the name as seen from? Great, that's about what I expected. Good, keep it that way. Don't use as seen from. Base type and member type are your friends. Base type has another version, base type seek, and it just tells you all the classes, all the super classes of a given type up to any. Like it'll always end at any. And the key thing that is tricky to understand about this is that it'll look at the type, and if it was a parametric type, it'll look at the type parameters you passed in, and it'll propagate them through all the way. And that's actually one of the core algorithms in the type checker to figure out, yes, Dick. Yes. So if you were curious, why not? Let's do this. I already have my pro color scheme REPL fired up because I didn't want to make you wait. So what type? Oh, let me just power it up. What type would you like to see? Well, I think that's an excellent reason to show it. Do you have a preferred element type? String? Not feeling very inspired. Okay, string, fine. Strong, yes. So let's just first see what it does with that. I have no idea why it's so slow. It's probably because it's not plugged in, and I need a new Mac. So that's the type. You'll notice that I've been cheating all along, and I haven't actually been showing you the full type. There's this prefix in there that you really don't need to know about, but the power mode and like puts the interpreter, and it's global, which is the compiler instance in scope like this. All right, so probably should, in preparation, let's see if it'll fit. Yeah. So, maybe I could just do something like this. Oh man, yeah. Don't tell people I did that. Okay, so now we know. back to the presentation. Thanks very much for that question. We could have picked a nicer type, but okay. So, but you know, does it make sense, or should I make a simpler example? Let me just keep it simple. So this is like, you know, we'll show you the basic version of the problem. You can see how slowly I type. That's why we're so bad at, yeah, that's not how you do this. This is why I never do live coding. Ta-da! So, makes sense. If I had done a more clever version, I could actually do it just more directly, and use Dick's favorite element type. And now you can see that it knows. Well, that's actually not super interesting, but it knows that it has to propagate this thing. In this case, it's super simple. But you can tell by the first line here. Oh, where did my cursor go? That it actually like knew that it's not C of t, it's C of int. That's like the key thing, and it does that for type members as well. Everything that it knows statically about the type and that is fully specified about the type, you can ask about members that are now seen like this, and that really like makes the whole type checker tick. I already got into demo time, so I have some more stuff fired up for you already. So I was kind of really depressed that IntelliJ already tells you this. Like, I don't know if you can read this, but it says method foo is never used, and here I was going to implement this in Abid. Damn you, IntelliJ. But let's just do this again, okay? Let's just do it again. So this is my little demo project. It's on GitHub if you want to look at it later. It's called Abid demo under my private repository. How about we start with the build? So I have two projects. One where I'm going to show you how to develop a rule in Abid, and this demo here, and there's a little comment there that you can go explore on GitHub that tells you about one of the many bugs that we already know of in Abid. In this case, I think it's SBT plugin. And so for the demo, you know, I don't think there's anything too fascinating about it. The key thing here is, I think you can double click on that stuff. Yeah. So this is how I add a rule to Abid that we're going to develop next, or that we're going to refine next, because I did do some typing already, knowing how horrible I am at that. So this is how in SBT you would activate your personal rule package that you published, and that we will publish right here. So this is the build for that one. You depend on Abid, which currently is in snapshot. Like it isn't published at all, so I just did a publish local of the repository, but that's really all there is to it. And you depend on the compiler at the current Scala version. I couldn't have gone to 2.12, but I decided to not venture too far because it is a demo. Oh, and speaking of, what Dean was saying here, some XML. So that was my talk. No, so if you're developing an Abid plugin, you basically have to write a set of, like, you have to list all the classes. Oh, and I can open this in Chrome apparently. So you basically you have to make this XML file. It's not terribly interesting, but I figured, it's XML, I'll show it to you. So this is our fabulous rule that is going to check for unused private members, or in general, like it doesn't have to be a private member, anything that you can assume the closed world for, and that you will see. And let's see, no, I don't want a breakpoint, I just want to expand it. Okay, so there's just very little that you need to import. You have the context, and you have this existential rule, which is kind of like a find. And this is, the boilerplate that you need to do. The key that we're going to put in our passed to our OK and not OK method is a symbol, as it very often should be. Remember what I told you about strings? We have to enter the name here. I mean, this is something, we're in 0.1 land here, so there are a couple of things that we could polish. And then you can define your own warning type, and it does have to extend rule warning. This is a little helper method that I wrote, and thanks IntelliJ, this is local block, is local to block now. And I kind of left that there. Oh, that's kind of disappointing. I left that there to remind you that the compiler API is, how you say that in those non-binding contracts, can change at any time without any kind of warning or courtesy or whatever. We're so evil that all we do is have like weekly sprints where we just change a bunch of names in the compiler API. Actually, I considered doing that to show people that we're serious about it and that you really should be ready to deal with breakage. And another reason why I want to have a nice layer in Abid that shields you from the compiler madness and gives you a bunch of methods that probably are enough. But as many of you, I'm sure, have written macros, I'm not going to ask for a show of hands because it's just too depressing. These things tend to change, and we do our best to keep them the same, probably a little too much. But this is how you would check whether a symbol is private or local to a block, and there's a ton of other kind of conditions you can figure out knowing the spec to really hone in on all those symbols, and this is kind of what I'm talking about with those semantic methods that we want to provide to you in the Abid framework, is that I really don't want you to have to write these things. I mean, this is something that we can kind of come up together, just stick it in the platform and let you write a bunch of other rules that use stuff like this. And that's where I see Abid's role, as we want to collect all this knowledge, we want to write that down as methods, we want to do that for you so that you can write rules and use them. And so then the core logic obviously is this step val that you call an optimize macro on, and that's kind of what takes care of the fusion and making sure that you don't call this when it looks at all the cases and it says, oh, it only looks at selects and defs. Let's not call it where those can't appear. And then I did the most naive thing possible. I just looked at my example here. I said, well, let's find all those method definitions. And I already kind of knew that I had to leave the potential for type parameters and an argument list and a result type and a right-hand side. If that tree symbol is in the closed world, put it aside and say this is potentially a violator, this is a private method, or this is a method that I could hope to detect all usages for internally just in this project. So let's keep a careful eye out for when this is used. And then I just looked at how would I use such a thing, and wrote down the Kwazii code, plugged in some holes, and said, well, if this thing, so if it's like a qualifier, dot a method call, and it is in this closed world thing as well. That's actually an optimization. You don't really have to do that. Then you say, it's OK. I've used this. This satisfies the rule that for all those symbols that are in the closed world, that are defined, like all the definitions of the symbols in the closed world, there must be at least one usage. I think this is an obvious example of a rule like this, right? But this, I think, is a pattern for many of the rules out there. And so since this is a demo, I should probably run some code at some point. How do you make that appear again? I'm kind of new at IntelliJ. I've been trying to show, what would this be? A term? Huh? Left. Aha. Wonderful. Thank you very much. This can go away now. Okay, so I actually already started SBT because I also couldn't, maybe you also know that. Can you run an SBT task from? I did, yeah. Okay. And then it should be an Abid demo. I made sure to be on all the latest versions so to look like a good user, but I actually spent half a Caltrain ride trying to figure out how to run a task, and I did task activation. I think I should probably be nice and report this. I think there's something wrong with the EAP or something. But this is where you would expect it to be, right? Okay, so I'm not. Maybe I set something up weird with my multi-project build or something. Okay. So I don't feel too bad about using the SBT console. And so let's run Abid on the demo project. That's how you do it. It's, Abid is the name of the task, and demo was what I named my project. And lo and behold, it works for this particularly specifically crafted use case. So I mean, no need to applaud. But can someone tell me? Oh, thank you. Wonderful. So can someone tell me how sucky this is? Like give a couple of ideas of how this might break already. Like I've been dropping major hits about the limitations of Kwazii quotes. But yes, multiple hands. Ah. I guess we can't do string here. Sorry, Dick. And we'll do int. All right, let's try this again. Yeah, I guess somehow that was okay. Ah, see about that. Yeah, so now my program is fine. It's clearly used. Thanks. So I mean, in fairness, I did see this coming. If we were to figure out how to fix this, I'm also very happy to take suggestions, or I can just start typing and we could go to lunch a little sooner. Or maybe it could actually be quicker to take suggestions. You've seen how poorly I type. Suggestions, anybody, how would we fix this? Could you yell a little louder? Yeah. So, I mean, I'm going to just get rid of all of this. And basically, that's it. Oh, shit, you made something go red here. So that would be tree.symbol.name. Yes, thanks, IntelliJ. That's what I wanted. I mean, by the way, I really like IntelliJ. I'm not in any way, complaining. My colleagues know I never do that. So we have to publish our rule again, and that just is a publish local. I didn't set up my SBT build in a very sophisticated way. I mean, you could have done that as a dependency, of course. But once I've published this rule locally, I can just run Abid again and crash the JVM. That actually is something I could repeat when I was trying this. It's okay. It starts up pretty quickly. It's nice out today, huh? Oh, there it is. So, I mean, applause for the gentlemen in the back who figured it out. And I mean, of course, similar things hold here. So as much as I really do appreciate Kwazii quotes, very often you'll find that they're a great way to get you started writing a rule, but using show raw, you will be able to tell what the actual AST is behind them and get the more generic case, because the AST is kind of designed so that you can do like the common things that compilers are want to do. So I'll just also show you that I know some of the names of the AST classes in there. An application in general will look like that, and of course I don't know syntax for pattern matcher, even though I implemented it in 2.10. One forgets so easily. Doing a lot of Java code, and I'm just kidding. So actually, the more general form of this piece of syntax is simply an apply, and let me just go somewhere and show you. Yes, there. So the most general form of something like this would be, blah, dee, blah, and then we'll use our good old blippy, and I'm mixing up things. We don't actually need a type description there. I was thinking about the definition case still. So if we ask for a show raw of this, it's going to get a little big, but we'll hone in. So it just trust me that this is kind of, this nesting works out if you select all of this. What this really boils down to is that this is a select, foo.meth. Then you go one level deeper into the tree. This is a type apply, where you apply a list of in this case, they're still idents because we haven't type checked this. And then the outermost node conveniently is the apply, because that's really what this expression is doing. So first you select something, and that's, by the way, you always have either a select or an ident as the qualifier, and then, well, unless you do really crazy things like putting a block in the target or something. But most cases you would have a select or an ident. Anyway, I think this was enough of a detour. So this is what it would look like actually. And I'm actually not going to prove that to you, except if people want me to, or if I have like tons and tons of time left. I actually don't know. Maybe I should take more questions instead. Yes.
So another question, like I think it's really nice about using the Kwazii posts that kind of handles names for you. Do you like how would you encourage people? Like if someone wants to mention a specific class by name,
Yeah, like the attributed ref stuff is what you're talking about. Yeah, so that's as I'm sure all macro authors in the room know, is that you always start at root, and you make a fully qualified name, and you have to be extremely careful and nice to the compiler, otherwise it's just gonna stab you in the back later. I actually don't have the Scala project open, I think. Let's do that live, see what happens. Yeah, I believe in the indexer, yes. Well, only one internal error. I am using the EAP, so, okay, so make attributed ref, I think, yes. Let's see, and the great thing is we actually don't need anything, an IDE that understands our code. We can just add def before that. Yeah, let's find stuff there. And Scala reflect internal is your friend. So this would be the case that you're looking for. And yeah, unfortunately, I haven't. This is not IntelliJ's fault. I haven't finished up. I'm setting the project up again, and that's really our fault for not shipping with proper IntelliJ thingies. But I can probably find that one in TreeGen right there. There's a ton of helper methods, obviously, in the compiler, because we do this all the time. And that is the main challenge of the macro API, which I dread to call it API. And the same thing holds for Abid. This stuff is hard, and we need your help to come up with a nice API. And the way to do that, in my opinion, is to kind of have a bunch of rules. I know there are a lot of rules out there already defined, and we'll be very happy to help you port them to Abid and to kind of extract the common API usage out of there and put them in a nice layer that will maintain in lockstep with the compiler, so you don't have to worry about names changing all the time. Not that they do that much, but this MK attributed ref is in this case the magic incantation to refer to a symbol on a type. We call those things pre's for prefix. Okay, yes, Joachim. Yes, this would integrate really nicely with a materialization of Scala Meta in the future. Yeah, so that's another way to deal with the abstraction layer on top of the compiler problem. And I look forward to integrating Abid with that, yes. Good point, I should have mentioned that. Yeah, thanks. Yes, behind there. Okay, so to repeat the question, can a rule look at the annotations on a type or an expression? Well, they're always on types. Yes, absolutely. The type checker sees annotations, and you get them type checked when you're running as a rule in Abid. So you know exactly which symbol they refer to. You don't have to look at the annotation and say, is the name of the annotation this? No, you can say, what's the symbol for my annotation in my library, and then compare symbols very quickly to find the annotations that you're looking for. Yes, that's absolutely, totally a good way to go. Yes? Should I throw the mic over to you, or?
Is there a way generically to sort of skip over synthetic code?
Ah. You stole that question. Yeah, so we were talking about this earlier. That's an excellent question. So the question was, the compiler generates a lot of synthetic code behind the scenes, like the getters and the setters, and a ton more that I prefer not to talk about. How do you skip those in your rules? Because they actually might violate your house rules as well. And so that's very much what I had in mind when I was talking about, I don't want you to have to care about what the compiler does, and this is kind of part of the semantic API that I would want in Abid, and this would probably be the number one thing that we, and in this case it's a compound answer because the compiler isn't super disciplined about tracking this, as I know you know. But we'd like it to be, and so this is an area for improvement, and I think this is one of the things where Abid has this can offer you this kind of value, where we will happily commit to maintaining that API so that you can write stuff on top of that. Yeah, but right now there's no easy way to do that. I can actually show you once I get to the right desktop. So this is the actual unused member rule that's in the Abid repository. And it does look at whether the symbol is synthetic, and that catches most use cases. There's also artifacts that are slightly different from synthetic things, but I actually couldn't tell you how or why. I could tell you when that was introduced and by whom, but I won't. So yeah, anyway, next question. Or comment, or heckle, or suggestion, or it's time for lunch. I don't know what time it is. Yeah.
In the rule that you've written up to present, you use okay and not okay.
Yeah.
Okay, making the not okay okay comes out of the existential rule, right?
Yeah, exactly.
Between those two depends on which rule you're actually implementing.
Yes, so the question is, where did the okay and the not okay come from? And he suggested the answer for me. Thank you. They come from the existential rule. So I guess maybe I can give you a different kind of example and show you where they come from and how this thing is implemented. So the existential rule in the Abid framework, which is all written by Nicolas, and we forced him to document stuff and everything. So that's the great thing about internships. There's this okay and not okay method that is contributed by them, and they track state, in which case is a map from the key type to whoever was put into the okay and not okay version, right? And so we definitely can imagine that there are more kinds of rules that you would put at this layer, and not in every single rule you would re-implement that logic, and. Yeah, so now I've talked a lot. Did I answer your question? He was about to say yes or no. Kind of. Okay.
Yeah.
Okay. Yeah, let's do that.
So follow on from that. So the okay there puts it into an okay state, the not okay puts it into a not okay state.
Mm-hmm.
That would imply that there's some kind of ordering here that if
No, you just kind of keep track, and then at the end of the traversal, the ordering. The importance of the ordering disappears because you do a full traversal of everything that you see in your closed world, right? And then at the end you decide, what's the intersection, right? Yeah. You wouldn't want, obviously, the ordering, yes, and that would be something that we would fix before we did an actual release. So that's the kind of scrutiny that we would love for people to kind of so. What I do want to say that I think it's very ready to start porting rules to and using if you're willing to just publish it locally and experiment with it. It is readier than many of the links I showed you earlier in the slide, in my personal opinion. I will also very happily admit that it's 0.1.0 is kind of stretching it as what we imply in quality. I saw multiple hands go up when I started talking again. Or maybe that was just people wanting to go out for lunch. All right, well, thank you very much. Look forward to seeing rules appear in the repository or questions later. Have a great rest of your conference.